Okay, now this is part 2 of this particular video. I would like to take you through the rest of the part of this paper. But before that, as our tradition in Proflan YouTube channel, we usually have an opening remark. Cell evolution is going to take two parts. If we are talking of a low mass star, it's going to start by the formation of a protostar. Remember, a star is formed when gas and dust particles called nebulae is drawn together by gravitational force. Gravity pulls these gas and dust particles, compresses them, increases temperature and pressure, and then fusion of hydrogen and hydrogen begin. Then the star starts becoming a star at that point, and the first stage is called a protostar. When there is nuclear reactions taking place in the core of a protostar, there will be outward forces. And also remember there is inward forces of gravity. And when outward force is equal to inward force, the star moves to a stage called the main sequence, which is a stable star. Now, when all the hydrogen is used up, because nebulae comprises of hydrogen, when all the hydrogen is fused and is used up, now the star collapses again at its own gravity, and then it's again compressed, and temperature and pressure increases for fusion of helium and helium to begin. And then when helium and helium fusion begin, there is enormous amount of energy generated, then the star expands to become a red supergiant. When all the helium is used up, the red supergiant cools down to form planetary nebulae and finally becomes a white dwarf, which finally becomes a black dwarf. But if it was a massive star, a star will move from a protostar and it becomes the main sequence, which is very bright. And then when all the hydrogen is used up, remember the star will collapse against its gravity. And then now once it's compressed, when all the hydrogen is used up, gravity, there will be no outward force. So the star will collapse against its own gravitational force. Then fusion of helium and helium begins. Then that star now becomes to another stage, which is called a red supergiant. From the red supergiant, this becomes a supernova, which is an exploding star which explodes to form either a neutron star or a black hole. It will form a neutron star if it was just massive, but if it was very, very massive from the initial stage, it becomes a black hole. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial. Now, moving to the next question here, the question that was tested here is the concept of Hooke's law, and we are told to sketch a graph to show the spring obeys Hooke's law. If you want to show that the material obeys Hooke's law, it should be a force against extension graph, and it should be a straight line. That means it obeys Hooke's law, meaning that extension is directly proportional to the force applied. Now, if it does not obey Hooke's law, you are going to have a nonlinear line, a curve. For instance, a rubber band will behave this way. So if you are asked to state how does the graph show that the material obeys Hooke's law, is when it's a straight line, right? Next, we are going to look at the diagram which shows an object suspended from a support using a metal spring. The object is initially at rest. The object is pulled down and then released. Is pulled down, so meaning the forces will be acting. There will be a downward force, and then there will be what? Upward force. Remember, weight acts downward. So when it's released, we are supposed the resultant force will be the difference of 3.2 and 2.4. So meaning 3.2 minus 2 shall have a resultant force of 1.2, which will be acting upwards. I was just using an example here to explain to my students that if we have a box of 2 kg and there is a force of 10 Newton pulling this side and another force of 2 Newtons this side, the resultant force will be the difference and the direction will be towards the right, towards the greater force. Next question is, the object has mass of 0.2, we are supposed to calculate the acceleration. We have already worked here the resultant force, right? Then if we are working out the acceleration, we're going to say the force, and the force we are talking about is the resultant force that we are having here. So we're going to say force equals to mass times acceleration. We know the mass, we know the force, we know the mass, force is the resultant force, don't forget. Then we're going to apply that formula and we're going to say force equals to MA, 1.2 equal to 0.2 times A equals to 6 meter per second square. There will be a greater downward force. So the moment it's released, there will be a greater upward force because the tension will be so strong that it will pull the object to move up. So the moment the object starts moving upwards, the speed of the object will increase, and that point air resistance also will increase. And remember, resultant force will be tension subtract the weight. So if there is another force which generated when the object starts moving, which is air resistance or drag, then it means the resultant force is acting upward, but the resultant force will be decreasing due to the increase in the drag or air resistance. When resistant force decreases, it means the acceleration of the object is going to decrease to 0. Remember, the object, as the object move up, tension also will be decreasing while the weight remains constant. So that's why I say that when the object is released, resultant force is acting upwards. As the speed increases, air resistance also increases so that the resultant force decreases. So if resultant force decreases, the acceleration of the object will decrease, right? Now, the next question, number 6, was a question from magnetism. So something you need to understand is that the fields are spreading away. They are moving away from each other. When the fields are apart, it means that's a weak magnetic fields. Near the poles, the fields are very, very close. They are close, meaning the strength of the magnet is strongest at the poles, right? And something else you need to remember is that the fields usually point from the north to the south pole. So you need to understand that the field usually point from the north to the south, and the fields do not cross each other. Those are some of the properties that you really ought to understand. Now, which of this is attracted by bar magnets? Remember, those materials which are attracted by magnets are called magnetic materials. So nickel is one of the magnetic material, plastic is non-magnetic, zinc is non-magnetic, copper is non-magnetic, wood is non-magnetic, glass is non-magnetic. You need also to understand, as you are going to review your exam, that we have materials called soft magnetic materials and hard magnetic materials. An example of a soft magnetic material is iron, and example of hard magnetic material is steel. So soft magnetic materials are those materials which are easily magnetized, but once magnetized, they lose their magnetism quite fast. And those materials are used to make temporary magnets. Hard magnetic materials are magnetic materials which are difficult to magnetize, but once magnetized, they retain the magnetism for a long period of time. So which means these materials are used to generate permanent magnets. Explain how the magnetic field show this. What do they want to show? The strength of the magnetic field changes as they distance from the south pole. You see, as you are moving from the south pole, I want to show you, as we are moving from the south pole, the fields, the spacing increases. meaning the strength of the magnetic field decreases, right? So the spacing of the field line increases, and the further the field are from each other, the weaker the field strength is. So equally, if I'm having magnetic fields which are like this, yeah, when they are close, it means this strong magnetic field, which when they are apart, it means they're strong, weak magnetic fields. Now, moving further, we are told that the piece of iron become magnetized. This iron is a magnetic material. So when it's put in a magnetic field, we say magnetism is induced in the iron. So which means that a north pole is generated at this side so that it can be attracted towards what? The south pole. But when this magnet is removed from the magnetic field, it stops being a magnet. So you need also to understand the law of magnetism, that like poles repel and like poles attract. If you are new to Proplan YouTube channel, consider subscribing so that in time we are going to upload further tutorials, you'll be notified. Now we need to explain why the piece of iron experiences a force toward the south pole. It experiences a force because when this ion is placed in a magnetic field, a north pole is induced next to the south pole. Then there will be attraction according to the law of. The student suggests the piece of iron is now a permanent magnet. The student is very wrong, because if this magnet is removed from inside here, it will cease being a magnet. So we can be able to say iron is a soft magnetic material, so it loses its magnetism quite. Right, so we need to move to electricity. And in electricity, we are told the diagram shows a domestic lighting system circuit, that is, and you can see we are given some currents here. This is the main supply of 230 volts. I was just discussing with my students when you're told milli means 10 power negative 3, mega means 10 power 6 million, kilo means 10 power 3. So those are quite important aspects you need to understand. Explain the advantage of using this circuit for this domestic lighting. So if you look at this circuit that we have here, this circuit is a parallel circuit. So meaning if one cell or rather one switch is open, the other switch, the other lamps will continue working. So which means that these bulbs and lamps can work independently from one room to another, because in a house you don't want a situation whereby if one lamp goes off, the rest are off. So parallel circuit has an advantage in that if one is off, the rest will continue working. And also all the lamps are going to having the same amount of voltage in the parallel circuit. So we're going to say the lamp works independently such that if one goes off, the rest of the lamps will continue working because it's a parallel circuit. Give the name of the charged particles that moves in the electric current, that is electrons are the one that are flow. So when electrons flow, when charge flow, that is the flow of current. We need to also look at what power is. We are told show that the lamp one has a power of 5 watts. We know that power is equals to voltage times current. Now you can see the amount of current that is here is 22 times 10 raised power negative 3, which is 0.02. But the voltage is to that because all these bulbs will be sharing the same voltage, which having the same voltage, which is 230 volts. So each of the bulb will be having the same voltage because this is a parallel circuit. So in order to work it out, we are going to say that power equals to IV, which means that 0.022 times 230 and that gives us 5.06 watts, which is equivalent to 5 watts. Calculate the energy. Remember, energy is equals to power times time, and time has to be in seconds. Working it out, this is exactly what we are going to get as 150 joules. And we are supposed to state what's meant by the voltage. This is the energy transferred per unit charge. Unit charge. Yeah. If you are asked about EMF, EMF is the amount of energy transferred or supplied to move a unit charge around a complete circuit. Switch 1, switch 3 are closed, which turn on lamp 1 and 3. Switch 2 is open. Calculate the current. So you need to understand that current will combine. So if switch 2 is open, meaning current will not flow here. So the current we shall have will just take this part and take this route, combine together, and that becomes what? 39 milliamperes. Milliamperes. Watch out for the third part of this video so that we can be able to do the final bit of it. See you in the next video.